Today we're going to talk about quantitative methods and begin getting into a little bit about survey research. So, quantitative research, generally speaking, easiest way to remember it is we're using it to quantify a problem. And that generally means we're creating numerical data, and the numbers themselves don't tell a story, and so we need to transform them into usable statistics. And so what that means is we need to get the numbers to tell a story that will give us insight into the question we're asking. And so we often use quantitative research as a way of measuring attitudes, opinions, and behavior. And so some of the reasons that we develop quantitative or skills involving surveys is we want to better understand the data we see in everyday life. We're often confronted with percentages, information from surveys, public opinion polls, so on and so forth. And so understanding how surveys are conducted and how quantitative data is gathered helps us better understand and become literate when reading information using quantitative data. We also want to see the format in which data is presented, think about possible uses for the data, and then determine what other data might be needed to answer a particular research question, or if we're reading a study that's already been conducted, what information might not be present that might provide a fuller picture of the question at hand. And so the methods, one of the things that quantitative research really relies upon is the idea of replicability. And so surveys and studies should be designed in such a way that it doesn't matter who collects or analyzes the data. And this is going to differ in many ways from interviews where personal rapport with the participant is very important. And so quantitative methods are designed to be somewhat person-free, and you're relying on questions and measures. And so we're going to talk about the various measurement tools used in quantitative work. And so to begin with, thinking about whether it's information or data, we have right now simply information. If we look at this image, they're words and numbers, but we really can't make any sense of them. We don't know what they would refer to or how to organize them. And so to turn it into data, we need to put it into a context and then organize it into a system. Right? And so data, then, are numbers in context. So we take this chart and we find out, someone tells us, or our client tells us this is data from personnel records. That's the context, right? That's the context that this information needs. Now we need to put it into a system. We need to put it into a system so that it makes sense to us and we can create meaning from it. And so here we go. We have a table. Personnel records for the University of Hard Knocks. Haha. And we see that Beaumont, Lee, and Smith are the last names. The numbers were employee number. The letters were gender, employment status, salaries, and leave entitlement. And now looking at this chart, you can probably begin to infer a few things about Beaumont, Lee, and Smith. For example, who do you think has the most power in their job, or who perhaps has been there the longest? You might guess that it would be Beaumont because the salary is the highest, and so they might occupy a higher position. And indeed, you can see here, if you look at employment status, both Beaumont and Lee are permanent employees, while Smith is a casual employee. Another thing you might infer would obviously be perhaps looking at days off. There's a discrepancy between Beaumont and Lee, but of course that could be that Beaumont's just taken a vacation or has recently been sick. But you can see already how the table organizing the data into a system begins to allow us to make inferences about the information we're looking at. And of course, we couldn't just make those assumptions and move on, right? Beaumont could occupy a equal position to Lee, but have been there longer, hence the higher salary, or some other arrangement might be made. Right, but we can make judgments about the elements of this information and then further interpretations. And so one thing to learn is there's a particular jargon associated with discussing tables and data. And so we're talking about variables and units of population. And so dealing with quantitative data, The columns represent specific variables, right? And so those variables in this context are employment status, employee number, sex, weekly salary, and leave entitlement. The rows show the data for a specific union. So Beaumont is the unit. And then the variables, and this is all the information associated with her. 95673, female, 1355, 12.6. That's the data. So you can see variables are easy to remember because they're the things that vary, right? The employee name varies, it is a variable. Employment status varies, it is a variable, right? The data is attached to the unit. And so Beaumont is a unit of the population being studied. If the population being studied is employees, then Beaumont is a unit, Smith is a unit. And so looking at the variation in this, you can see that not all employees have the same employment characteristics. And so one of the things statistics and quantitative research does is it examines variation and reports about it in newspapers, magazines, television, and the internet. And so the work of quantitative work is to find variation and determine the meaning among that. And so most of us are pretty familiar with women make 70 cents on the dollar, right? And that's the statistical information that's been taken from several studies and brought together to kind of arrive at that number. And one of the debates among it is, how are you comparing that? What is your data? And how are you controlling for various variables, such as length of time, such as education, so on and so forth. And so one of the things when statistics are reported in newspapers, magazines, television, and the internet is that it's important to check the methodology and see how they're constructing these things and or go with a source that you trust and that is credible. And so this is an example. Bert was a researcher, a psychologist who worked on identical twins, looking at their levels of intelligence. And one of the things that might stand out at you here is that there really isn't a lot of variance. We don't have these numbers going across several years, don't vary at all. And that is suspicious. We would expect to see some variance in the levels of intelligence between these twins reared apart and twins reared together, given the cross-section. And so the results that he had showed a high association between intelligence and heredity, and that was generally accepted for a rather long time until shortly after 1966, researchers noticed that there was too little variation. A little suspicious, they went back through his data and found that he had been fudging the numbers. And so, thinking about that, variation, we should expect to see it. And so that's one of those things to keep in mind when you're looking at your data or the results, that some variation, you want to be able to acknowledge errors or variation. Not everything's going to look neat and pretty. Okay, bringing us to some other jargon terms, population and sample. And so when thinking about data analysis, population is the complete group of entities. So population would be every student enrolled at Cal State Fullerton, or all the sales territories for a particular product, or all the restaurant chains for TGI Fridays. And so that's the population. And now when you're doing a study, you don't have the time or the energy, and it's not really necessary to interview, poll, survey every member of the entity. So we don't need to interview or survey every student at Cal State Fullerton to get good data. What we need to do is decide on a sample. And a sample is a subset of a larger population. Choosing a sample is helpful because it improves cost and time. And if we choose a sample well and we adhere to general good data collection methodologies, the information from the sample allows us to make inferences about the population. And so in this case, we've got a population of a lot of ants, and we take a sample of 9 ants. And so one of the things that what sampling does is we're basically saying that among these 9 ants, there's going to be variance, right? These 9 ants aren't going to all think the same. And among that variance, we're going to also have the same variance or similar variances among the rest of the ants that we did not directly question. And so variables insist that samples collected from the same population will differ. The differences indicate the variation within the population. Difference tells us something about a population. We're not all clones. We don't all think alike. Variation in a property or characteristic of a population can be measured. So with quantitative work, again, what you find as your results is the level of variation of a property or characteristic within a population. And so measurements of these properties are called variables, right? And so the property of being male or female in the previous example was a variable, right? That would change, that would vary. And so a variable is any factor that can exist in differing amounts or types. High or low can be determined by value. And so one of the things we do in quantitative work is we assign numbers to less coherent or generally intangible things such as affection or like, dislike, right? We put a value on how much we like or dislike something in a Likert scale, right? And so the values assigned determine how much further the data can be processed. And so what does that mean? It's really, it sounds very abstract, but if you only have 2 ages on a questionnaire, old and young, you don't really get a good sense of who marks themselves as old and who marks themselves as young, right? Or you might, even if you had ages, 1 through 50 is young and 50 to 100 is old. Now, there's going to be large variances between a 10-year-old and a 50-year-old, right? Similarly, between a 52-year-old and a 78-year-old. And so that's going to be not enough, you don't have enough variables in there to really process your data meaningfully. Similarly, young, middle-aged, old, you're getting there, but it's still very vague. And on the flip side, we have rational values, where you're counting everyone by year. And now that might be almost too granular. It might be too fine-tuned to really hold any meaning, because there's probably not a huge difference between a 42-year-old and a 45-year-old in most things, based on age alone. And so in this example, right, the unit member is any one given smiley face, the population is all smiley faces, and the variable is the color of their faces. And so one type of study that would be done, sort of a survey, is a census. And we're familiar with this from the U.S. Census that's conducted. And that's studying all elements comprising a population. So we look at all units individually in all their specialness. And so one of the reasons we don't normally do this is because it's expensive. It costs a lot, and it's very difficult to get people to comply. And so to actually survey all units. Okay, so when we sample, we as I mentioned, choose who among the population we're going to sample. And there's several different ways, excuse me, to do this. One is a probability sample. Each person or unit in the population has a known or calculable chance of being included in a sample. Which means that we could tell you with a percentage what the probability of you being chosen is. Now, most samples, especially for the type of work we do, would be non-probability samples, where the probability of selecting each member is unknown. And what this does do, though, the problem with a non-probability sample is it makes generalizing data from the sample risky. And so depending on the information you're looking for, if you're looking to see how people feel about a particular brand identity and you've got a very narrow group and you don't have a lot of time or money, you'd probably want to go with a non-probability sample. If you're perhaps conducting political polling or something similar, you might want a probability sample. It might be much more important to fine-tune that. Or perhaps if you're, researching pharmaceutical drug testing, something like that, right? You'd want to know what the probability that a particular person would be included in that study might be. And so probability samples, some of the ways we do them, it's simple random sampling. Each and every unit has the same probability of being selected. The sample should contain members with characteristics similar to the population as whole. And you need a complete list of the population, which we call a sample frame, to randomly select the units for the sample. And so that would be if, say, we were doing a study of all Cal State Fullerton students, we'd want to make sure that the members of our sample had characteristics similar to the population as a whole. So that might include thinking about gender breakdown, ethnicity, race, socioeconomic background. And then we'd also want to be able to calculate the probability of somebody being selected. There's also systematic sampling. So we would take a list of students at CSU and put them in alphabetical order, pick every nth name from the sample frame. So if we pick, every name within 1 to 10, we pick 7, then number 17 gets chosen, number 27 gets chosen, and so on. So that's systematic sampling. And so one of the ways this looks like to give you a visual is you're sampling every third, right? So we've got our populations all lined up, 12 of them. You'll notice there's different characteristics. And what happens with this method, though, even though we can tell you the likelihood of somebody getting chosen, you might notice that in our sample, where we took every third, right, we're missing blue. And so whatever variables or variances in the population blue might represent are not represented in our sample. Right? Another type of sampling is stratified random sampling, and that type of sampling works to rectify the problem we saw in the last example. So you divide the population into layers of strata, and this is then to create representativeness. The sample is proportional to the strata present in the population, and so you'll notice that there are twice as many reds as blue and greens. So therefore, there's twice as many reds as blue and green in the sample. And so the proportions are still reflected, but every member does not have the same chance of being selected, but there's a probability that they can be selected, and we can calculate that through the wonders of math. Right, so strata to sample. Another way of doing this is through a cluster sample. The population is divided into groups. This is usually used geographically. And then their groups are randomly selected. And then you would go from there to a simple random sample or a census in the chosen groups. Now we have non-probability samples. And in these, as you might imagine from the chance of selecting any member of the population is unknown. And so it's a more subjective process than the probability samples, where we're trying to really take that choice out of our hands and leave it to math. And so one of the most common ways, and one of the things you'll probably be doing in this class, is convenience sampling. We do this because it's convenient. It saves time and money. And so members are chosen because they are ready and willing to be involved. The drawbacks are that it might not be representative of the population. There's a volunteer bias. And so one of the things is that people who choose to participate are not necessarily likely to be representative of the population as a whole. And so you're dealing with whatever personal traits or feelings people have towards the things you're studying that urges them to volunteer to participate. Another thing to consider would be location. Sometimes if you were to do a survey outside of a polling place, the person might have a viewpoint they're very interested in advocating for. And you don't want to set out to completely identify, and with convenience sampling, you don't set out to completely identify the population being studied. So you're interested in getting enough results to kind of give you a guideline, but you're not going to identify completely or claim to be speaking for all women 35 to 45. Another type of sampling is a judgment sample. Samples are selected by an experienced researcher based on his or her judgment about appropriate characteristics required of sample members. And so this is after you get some experience and you begin to think about what types of person you want. And if you think about target audiences, you begin to get a sense of how this might work, right? You might want to have a few soccer moms included, as well as a few full-time working moms, as well as a few single moms, and so on and so forth. Now, you only include relevant members of a population. So in the example I just gave, you're clearly advertising towards mothers. Convenience samples, you might not get that many relevant members of a population because you're simply going with who comes to you first. Now we also have quota samples. So you have some knowledge of the population, you can build representativeness into the sampling plan. And then, so the participants are selected according to pre-specified characteristics, demographics, attitudes, behaviors, and so on. And so, an example, if we were to conduct a study of Cal State students in the Department of Communications, we would perhaps try to choose people that would match the quotas. We'd have a proportional number of students from each degree program, and then we try to match the demographic information as well. And then the likelihood of being chosen, though, cannot be quantified, and that's what differs this from a stratified sample. Another example here, we have a snowball sample. And so that would be something where you talk to one person, and this works really well if you have sort of an odd research project. A few semesters ago, the students had a research project looking at a dog walking app and how to improve it. Now, the application was developed for dog walkers to use. And so you're looking for people who are at least semi-professional dog walkers, or at least get paid to do so. And so that was an example where a snowball sample was really helpful because you found one or two people who qualified, and then you ask them if they know anybody else who would participate in the study and who would qualify. And so because dog walkers are more likely to know other dog walkers, and that's also a population of people that we would have no real sense of the entire, we couldn't do a census of. We don't know how many dog walkers there are or what their demographics necessarily are. A snowball sample was the most effective for that. Okay, that brings us to survey research. So, couple steps to good survey design. You want to identify the survey's purpose. If you start writing a survey without any purpose in mind, you're not going to have very good data after you do the work. And you want to specify the population on which the survey will focus. Who are you speaking to? Thirdly, you want to identify the resources available. How much time do you have? Are you going to do it in person? Are you going to do it with several people? Is it online? How are you distributing it? How are you collating the data? Okay, so surveys, definitionally, are questionnaires given to a selected group of people. The sampling concentrates on a small proportion of an overall group. So the advantages to surveys are that they're easily quantified. Large groups can be studied. Researchers can always use an agency. They can hire out people to collect responses. The disadvantages are that the findings might be superficial or doubtful, and the level of non-response is high. And so we have, often I'm sure you've all started taking surveys and then decided, I don't want to bother. Or when we get surveys from customer service feedback, we often just ignore them. I'm always hanging up my phone on them. And so that's one of the disadvantages of surveys. And then you also have the findings might be superficial or doubtful. When we talk about quantitative work, right, we learn a little about a lot. And so between questions of replicability and validity and then response, a lot of care has to be taken to make sure that the findings are both meaningful and credible. So when we talk about surveys, we have a couple different scales we use in designing a survey questionnaire. First one is a nominal scale. It tells you which group or unit a unit or individual belongs to. And you're going to use this to categorize. And the coding of a nominal scale does not imply order. And so that would be something like male, female, right? Or non-applicable. Or no answer, right? You want to have, it's a group, but there's no order to it. The numbers that you assign it don't necessarily imply anything. An ordinal scale, however, shows order, right? Ordinal order. One unit has more of a characteristic than another unit. And so it's a ranking system. And so we think about measuring feelings, right? Strongly disagree is a lot less agreement than strongly agreeing. And so, all right, so those are measured on an ordinal scale. We also have interval scales. The difference between measurements is meaningful. And so one of the things here to look at is there's no real way to quantify exactly how much difference there is between strongly agree and agree, right? That bar is going to look somewhat different for everyone. And so that's not necessarily a meaningful difference. We assign it meaning, but we have to keep in mind that that's a little bit of it's a construct. It's something we do to make sense of things and move on. But there's no real way to quantify that. There's no meaning in that difference. Interval scales, however, do have meaning in their between variables. And so difference in age, right? Between 10 and 15 is 5. 20 and 25 is 5. Those are the same intervals, and there's a numeric value. Ratio scale is a form of an interval scale, but it has a true 0. So that would be something thinking about weight, right? You can weigh 0. Money, you can have 0 money, but the distance between variables of units of money have meaning. And, temperature in Kelvin, right? Absolute 0. So some visualizations of this. Levels of measurement, right? Nominal, we've got ourselves gender. Ordinal, position in a race. And here you can see in this example that, right, the spaces aren't the same. Right, so if you're fourth, it doesn't mean that you came in the same distance behind third as second did from first. Meanwhile, interval it's in Fahrenheit because there's no absolute 0. Right, there's ordered equal differences. And then ratio, you've got 0, and we see money being used as the example. So some things to think about is what type of survey you might do, what the mode of application is. So you might do it by mail, over the phone, online, or in person. This is going to depend on the type of data you're gathering, how much time you have, the cost, and who you're trying to reach. If you're trying to reach people perhaps ages 60 and above, online might not be the best place. Right? You might get better results and better response rates from doing it on the phone or through the mail. If you're trying to reach 15 to 25-year-olds, online probably would be better than phone or the mail. In person might be good if you're looking for people shopping at a particular store or in a particular geographic location, right? Because then you know they're there. And so these are things to keep in mind when we think about survey design and administration.